Jim Lovell, and I have the honor and privilege of serving as the president of IMSA Student Council. On behalf of the entire Illinois Mathematics and Science Academy community, I welcome you all, students, faculty, staff, and guests, to the 5th Annual James R. Thompson Leadership Lecture. The Academy's foundation, the IMSA Fund for Advancement of Education, is pleased to provide this opportunity for students from schools in Aurora, Chicago, and all over the state. Before you leave, we hope you have a sense of pride and faith we have in our community. We know you have shared in our anticipation of this day and the excitement of its coming. I know you will enjoy the lecture. At this time, I would like to introduce the Academy's Executive Director, Dr. Stephanie Pace-Marshall.
Thank you, Sindhu, and good afternoon. On behalf of the Board of Trustees, the faculty, staff, and students at the Illinois Mathematics and Science Academy, welcome to IMSA and the 5th Annual James R. Thompson Leadership Lecture. I want to echo Sindhu's welcome and say what a sincere pleasure it is for us to have all of you here this afternoon. We welcome you as IMSA partners and friends. Without your continued support, events like this would simply not be possible. Unfortunately, Governor Thompson, the man in whose honor this lecture is established, was not able to be with us this afternoon. However, we know that he is a big fan and admirer of Dr. Lovell and asked me to say that he would be here in spirit. And so in the spirit of Jim Thompson, I welcome you also. At this time, I'd like to recognize some special friends of IMSA who are here today. We are delighted to have so many members of the Illinois General Assembly with us. They have been strong supporters of the Academy, and we have been grateful for their leadership over the past almost 10 years. We look forward to their support during the next decade as IMSA positions itself for an even greater leadership role in Illinois and the nation. We are also excited to welcome over 700 teachers and students from more than 70 schools in Illinois, as well as members of the IMSA Board of Trustees, its President Jim Pearson, the IMSA Fund Board of Directors, its President Michael Burke, and local government officials, including our Mayor David Pierce. Finally, we are delighted to welcome over 100 of our corporate foundation and individual donors to the IMSA Fund for Advancement of Education. We continue to thank you for your generous support and encouragement. In a very short period of time, the Thompson Leadership Lecture has become a treasured tradition for the Academy and our partners. Each year, this lecture enables us to invite distinguished leaders in science and the arts to our campus. We were fortunate to have Dr. Carl Sagan at our inaugural lecture 4 years ago. Dr. Edward Teller was our guest 3 years ago. Dr. Maya Angelou spoke with us in 1993, and Dr. Sally Rye was with us last year. Captain Lovell's presentation is a major contribution to this stellar list. At this point, I'd like to introduce to you Mr. Robert Malott, who will introduce Captain Lovell. In light of the Academy's mission and our focus on integrative ways of knowing and connections between and among mathematics, science, the arts, and humanities, we could think of no one more appropriate than Robert Malott to introduce Captain Lovell. Mr. Malott is chairman of the Executive Committee of FMC Corporation in Chicago, one of the world's leading producers of chemicals and machinery for industry, agriculture, and government. And he also serves as vice president of the board of directors of the IMSA Fund for Advancement of Education. Mr. Malott began his career in FMC in 1952 after serving 2 years as assistant to the dean at Harvard in the Harvard Graduate School of Business. During his long career with FMC, he held successive line and staff management positions. He was first elected an officer of the corporation in 1966. In 1970, he was elected to the board and became president and chief executive officer in 1972. And then in April of 1973, he was elected chairman of the board and served as chairman of the executive committee since 1991. Mr. Malott holds leadership positions in numerous national and international groups, including the U.S.-Russia Business Council, the Hoover Institution, the Aspen Institute, the National Board of the National Museum of Natural History, and the National Academy of Science, and the Lyric Opera of Chicago. He also serves as a member of the Board of Directors of Amoco Corporation and United Technologies Corporation, as well as the Board of Trustees of the University of Chicago. Mr. Millott is also a longtime personal friend of Captain Lovell's and of IMSA. Please join me in welcoming one of Chicago's premier business leaders, Mr. Robert Millott.
Thank you very much, Stephanie. I'm delighted and honored to be able to introduce my friend Jim Lovell, who, as you know, is a man who needs no introduction, as the 5th annual James R. Thompson Lecturer. Jim is among the pioneers of that elite corps we've come to know as having the right stuff, namely our astronauts. He has logged more than 5,000 hours of flying time, and at one time held the record of more time in space than any of his colleagues. He has written a best-selling book about his ill-fated adventures en route to the moon in 1970. And many of us have relived that momentous space flight as we watched on the edge of our chairs this summer's film, Apollo 13. Born in Cleveland and reared in Milwaukee, Jim studied mechanical engineering at the University of Wisconsin at Madison, then transferred to the Naval Academy in Annapolis, where he graduated with a Bachelor of Science degree in science. And at the same time, he developed a real yearning to be in space. The year after the Soviets launched Sputnik, Jim reported for service as a test pilot for the Naval Air Test Center in Maryland. It was this experience that provided the proven courage and the stamina, to say nothing about the flying experience, that Jim would need to pass muster and be selected as one of NASA's chosen few in 1962. 3 years of training followed, and in 1965, Jim and Frank Borman took their first trip into space, a 14-day trip aboard Gemini 7. That was in 1966. He and Buzz Aldrin flew the last Gemini mission aboard Gemini 12, and in 1968, Jim served as command module pilot, joining Frank Borman and Bill Anders for the first orbit of the moon aboard Apollo 8. And in 1970, after Neil Armstrong took mankind's first leap onto the lunar surface, Jim, with hopes of taking such steps himself, led fellow astronaut Fred Hayes and Jack Swikert in the Apollo 13 mission. We all vividly recall the drama of that flight after an oxygen tank exploded and put the ship and crew at high risk. The globe abruptly shifted their attention from a trip to landing on the moon to the life and death consequences of a risky return to Earth. Jim's brilliant and compassionate leadership of a tiring, fearful crew has earned him a place as a true American hero. The aborted Apollo 13 mission became Jim's last venture into space, and in 1971, he became Deputy Director of Science and Applications at the Johnson Space Center, after having flown a record 715 hours in space. 2 years later, he retired from NASA and as a captain in the U.S. Navy to enter private business. Jim first joined a harbor and coastal towing company in Houston, and then became president of Fisk Telephone Company, which in 1980 was acquired by Centel. Jim moved at that time to Chicago, where he became president of Centel's communication company. A decade later, In January 1991, Jim retired from the telecommunications giant as executive vice president, and today he directs his own company, Lovell Communications. Incidentally, Jim is past chairman of the President's Council on Physical Fitness and remains involved in that program even today. I am lucky enough to consider Jim a good friend. We've sailed together, vacationed together, and even went to the North Pole together. Incidentally, at the time I organized a trip to the North Pole, I listed the 10 or 15 craziest friends I could think of to see if I could get anyone to join me. I can report that Jim was the only person who, over the telephone, said yes. And he said, you know, the fastest time I've ever gone around the world is 1 hour and 10 minutes. And he said, I've been looking for a faster way to do it, and I'll go with you. Jim, always the adventurer, is an unassuming, a thoughtful, and a very good-hearted companion. Jim, join me in welcoming astronaut Jim Lovell, who has indicated that following his address, he'd be glad to take your questions.
Thank you, Bob. Thank you. Thank you, Bob, for that very, very kind introduction. Ladies and gentlemen, it's extremely much of a pleasure for me to be here, to be part of the Thompson Leadership Lectures. I've heard so much about this institution that I think that everybody who goes here should be proud to be a student or a faculty member of this school, because it is really one of the unique educational institutions in the state of Illinois, if not throughout the entire United States. Forgive me, if you will, if my voice sounds a little low. I am not the bass at the local choir. I found out from my granddaughter, who is a germ generator, that if you play with her too much, she's liable to give you the cold, so that's what I am fighting right now. I thought I would start out a little bit different by actually mentioning something that perhaps is on a lot of your minds about the movie. Is the movie accurate? Yes, the movie is very, very accurate. Did Tom Hanks play a very good part? I thought he did, although... I might mention something also. I first met Tom when he came aboard to do the project. I was one of the people that took him through the Johnson Space Center on an orientation visit. And during that period of time, he pulled me aside. He said, Jim, if we're going to make a movie out of Apollo 13 and I'm going to play your part, I have to know a little bit more about you. I have to know your mannerisms and your sort of your characteristics and how you speak, and maybe some of the cliches that you use all the time. And I said, Tom, my main home is down in Texas. I have a home at a place called Horseshoe Bay. Why don't you come down there? It's sort of secluded. No one's going to bother you. Spend a weekend with us, and then you can learn more about me. So he did. My home is about 50 miles from Austin. He flew in Austin. I have a small airplane down there. I flew over to pick him up, got him in the airplane. The flight from Austin to Horseshoe Bay takes about 15 minutes. I took an hour and a half going over there to Horseshoe Bay, and I decided to tell him all about being a test pilot. And I started to do approaches to stalls, and I did so those unusual maneuvers that I was trying to rack my brain that I did 25, 30 years ago as a test pilot. I noticed that Tom was a little quiet over on the right-hand side. He had been used to flying big commercial airplanes and those big executive jets, but these small airplanes sort of got to him. But he stood there, he braved it all, and I was trying to really give him in the mood of this type of work. And as we were flying along, I said, Tom, as soon as I found out that you're going to be on this picture, my wife and I immediately went out and saw the movie Philadelphia, which was playing at the time. And then I said, but didn't you make another movie since that time? And he said, yep. And I said, what's the name of that movie, Tom? He said, Gump. I said, Gump? Yes, he said, Forrest Gump. Hadn't been out yet, of course. And I said, what's it about, Tom? And he proceeded to tell me what it was all about, and I thought to myself, oh my gosh, I got to make him into a test pilot, an astronaut, a naval aviator. Forrest Gump goes into space. I can see it now. As Bob mentioned, I was very happy to make 4 flights into space with the space program, and that period of time that happened to be very unique in our space activities. A lot of research and development was going on. And my first flight, of course, was Gemini 7, Frank Borman, 2-week mission to find out if man could live in space for 2 weeks. That was the maximum length of time to go from the Earth to the moon and back again. That was a very unique flight. Do you happen to know what Frank Borman's second career was? He was at one time chairman of Eastern Airlines. Years later, before Eastern went down the tubes, I was on one of Eastern's airplanes. I flew into Miami. I ran into Frank at the Miami airport. I said, Frank, you know, I swear that the food you're serving on Eastern was left over from our Gemini 7 flight back then. He doesn't appreciate my humor. For those of you who might be going into medicine or biology or something like that, I just might mention a few things about that flight. It turns out that man can live in zero gravity as well as he can here on Earth. None of the body functions, or all the body functions, function primarily the same way that they do here on Earth. You can swallow, you can breathe. There are some differences though. First of all, when you first get into space, your head feels full, like leaning over a horizontal bar. All of you as small kids have probably done that, and your face seems to be flushed and full because the heart is still pumping as if it is working against gravity, and it feels quite full. About 6 hours later, you feel more normal. And the reason is that the heart slows down about 10 beats lower than it would be here on Earth. If your hearts are now beating at, say, 72 beats a minute, in space, 62. Why? Because the heart does not have to pump blood against a hydrostatic pressure of about 1.5 feet. And so something tells the heart, slow down, take it easy. In space, for anybody who has heart trouble, it would be a very good environment because some of the stress is taken off the heart. As a matter of fact, there's no one here that could not survive very nicely in the environment of space. Blood volume decreases. Blood is less in space than it is here. As we need to replace blood, something tells the body you don't need as much blood because we have more blood than we need right now because gravity tends to pull our blood down to the bottom of our legs, and our muscles had to be in tune to act like G-suits to keep the blood from draining down into our legs and, of course, causing us to faint. Those of you who have perhaps been sick for a couple weeks and are in bed and suddenly get up, you know what I mean, that you feel kind of dizzy. That's why it's so important to have good leg muscles, not in space, but back here on Earth. That's why you have to exercise every day in space to come back to the rigors of Earth's gravity. Because if the leg muscles are deteriorated, then your blood will drain down and you'll get what we call orthostatic hypotension. Blood will drain down. So basically that was a flight really to find out if man could live in space, and of course we can. That was a very good flight, 330 hours. Frank, of course, is right here. One of the big problems we had was the food. Where do we put all the food for 2 weeks in a spacecraft not much bigger than a number 10 tin can? The nutritionists were quite worried about that. They came to us before the flight and said, you know, we're having a devil of a time trying to figure out where to put food. Do you like fruitcake? We said, yes, we like fruitcake. Why? They said, well, fruitcake has a lot of calories for its size. It can be packaged very nicely. It's moist, so that in space, when you break it open, tear it in half or something like that, it won't crumble like a cookie. And we said, okay. They said, we'll put some on board. We took off in this flight. I was the co-pilot, the chief cook and bottle washer, everything else. Our first meal as we drifted over Africa was lunch. I reached back on the long string that had tied all of our food packages, got the first 2 packages, gave Frank his, opened them up, and mostly for lunch we had that freeze-dried stuff where you have to add water to it, mush it up. Wasn't bad, but not too good. But for dessert, we had fruitcake. And by gosh, the nutritionists were right. The fruitcake was very good. The mission went on, of course. Next meal was supper. I reached back to get the food, gave Frank his, opened it up, and for dessert we had fruitcake. We had fruitcake 3 times a day for 14 days on that flight. Years later, I was on the board of a baking company here in Chicago. Do you know what they sent to us for Christmas? I finished up the Gemini flights very nicely with Gemini 12, moved on to Apollo 8. Apollo 8 was going to be an Earth orbital mission. A mission where we take the command module, the mothership, and the lunar module, the vehicle to land on the moon, take them around the Earth, test out the vehicles completely before we ever committed them to go to the moon. But 2 things happened in the summer of 1968 that changed our flights completely. The first thing, Grumman aircraft, working very hard, trying to get the lunar module ready for a 1968 flight, finally came to us and said, we can't do it. It's impossible. We're never going to get the lunar module ready before 1969. Then we had a little bit of a more subtle piece of information from the Central Intelligence Agency. They said the Russians are going to put a man around the moon in the late fall of 1968. As a matter of fact, they were very serious about it. In the summer, they brought out a rocket. Sitting on top of that rocket was Zond 5, a spacecraft. They fired it to the moon. It went around the moon, came back again, landed in the Pacific Ocean. They went over to pick up the rocket, open it up, because it had small animals aboard, to find out if this was a feasible flight for humans. When they opened up the hatch, the animals had died. The re-entry was so steep, the acceleration so great, that nothing lived. But they were very persistent. They brought out another rocket, the Zond 6, fired it to the moon, and modified its re-entry. They recaptured, or they got that back again in the Pacific, opened it up, and the animals were well and alive. But they were very cautious people, believe it or not. They didn't want to commit a man to go around the moon unless they could repeat that flight. So they brought out Zond 7, with Zond 8 all set to go for the manned flight. Zond 7 took off. The booster never got beyond the atmosphere before it blew up. That was the end of any kind of a space race to put people near the vicinity of the moon and back again. We didn't know this at the time. We did know that what they were planning to do, and we had some very bold leaders in that time who said, look, we can't go around the Earth because the lunar module is not ready. Let's send Apollo 8, the command module, to the moon. And that's how it came to pass that on December 21st, 1968, 3 of us, Frank Borman, Bill Anders, and myself, took off for the very first flight to the moon. My most awe-inspiring flight, to be one of the first 3 people to see the far side of the moon. As you probably all know, as the moon revolves around the Earth, it rotates on its axis. We never see the far side from the Earth, only the near side. And we were like 3 school kids looking into a candy store window with our noses pressed against the glass, watching those ancient old craters go by. Really a magnificent sight. And then as the spacecraft went around to the near side and we looked up, we saw the Earth coming out of the lunar horizon. It is the only color you can see from Earth from that point of view. The moon, regardless of what pictures you have seen, is nothing but all shades of gray. The sun is too brilliant to look at. The stars, you can see only when you're in the part of the moon that hides the earth shine and the sunshine. Then they come out. Other than that, with the earth, the moon, and the sun in the field of view, they're washed out. But the earth, very beautiful. You can see the blues of the ocean. You can see the white cloud patterns. It came up on its side, so you can see the Arctic and the Antarctic ice caps, very, very, very noticeably. And in the desert areas, you can see the pink colors, the salmon colors, the browns, the tans of the desert areas. A wonderful sight. Borman and I saw that and said, by gosh, we've got to take a picture of this. Anders was in charge of photography. He didn't see the Earth come out of the lunar horizon. He said, hold it, we have only so many frames of film, and we can't waste it taking pictures of the Earth. And then he looked up and said, by gosh, we got to take a picture of this. All three of us took pictures of the Earth coming out of the lunar horizon. One of those pictures became very, very famous. You have all seen it in your lifetimes. It was made into a stamp in 1969. It is called Earthrise. It has been on every single publication known to man. It's in the public domain. Now, in your travels, should you run into Frank Borman, ask Frank who took the picture of Earthrise. He will say, I was the commander, obviously it's my picture. Should you run into Bill Anders, ask him, and he'll say, I was a photographer, that's my photograph. Ladies and gentlemen, I took that picture of it. Let me mention one more thing about that particular flight that impressed me the most. When we saw the Earth out of the lunar horizon, I could put my thumb up to the window and completely hide the Earth. I mean, everything that I ever knew is behind my thumb. My family, all my loved ones are behind my thumb. My country is behind my thumb. The oceans are behind my thumb. The problems of the world are behind my thumb. It really gave me a feeling of how insignificant we really are, how humble we are, that everything that I've ever known, I could then take a look and just hide it with my thumb. And when you really look at it from just the position of the moon, you realize that we are very, very fortunate to be alive and see things as we do. The Earth is just a small planet orbiting a rather normal sun, tucked away in the outer parts of a galaxy called the Milky Way, only one of billions of galaxies in the world. And yet, we are very fortunate to be alive and to appreciate everything we see. That was a very unique flight. Got back, landed, everything worked fine. I was recycled immediately to be Neil Armstrong's backup on the first lunar landing mission. My job was to make sure that he was healthy. I exposed him to the measles, but that didn't work. And then finally I was reassigned to Apollo 13. 13 was going to be a little bit different. We were going to land in the hills of the highlands because we had plenty of material from the Mare or the seas where 11 and 12 landed, but nothing from the hills. And we thought the material might be different. So we were going to go to a place called Fra Mauro, just about the center of the moon if you look at it on a full moon. We took off on this flight on April 11th, 1970 at 13:13 Central Standard Time. Right there I should have known something was going to happen. The big Saturn V took off perfectly like it had before. On the way into Earth orbit, however, on the second stage, the middle engine of the 5 engines on our second stage shut down 2 minutes early due to high vibrations, and a safety switch shut it off before it would disintegrate. For a second or two, I thought, by gosh, there's the crisis right now. What is going to happen? Do we have enough fuel to go into Earth orbit and then go on to the moon? Do we have enough power to keep going? Well, it turned out that we had both. And we did go into Earth orbit. It took us about an extra minute and a half to get there, and then we fired ourselves to the moon. I said to everybody, this is the crisis of this flight, because almost every flight has something go wrong with it. And this was the one on Apollo 13, and we're already through it. Everything is just fine. The course that we took to the moon was called a free return course. That meant that if something should happen to the maneuvering engine on our rocket ship, on our spaceship, if it wouldn't fire for some reason, the third stage put us on a course that would take us to the moon. The moon's gravity would swing us around, aim us back towards the Earth, and just with the little attitude rockets of our vehicle, hopefully make a safe landing back on Earth. And that's why it is called a free return course. About 30 hours after we took off and the ground tracking us on that radar, they called up and said, Jim, if you want to land at this place called Morrow, if you want to see the shadows of the rocks as you come down to that hilly area to miss those rocks when you land, you'll have to get off the free return course. I said, fine. The spacecraft was working very nicely. They told us how to maneuver the spacecraft. We lit the maneuvering engine. It worked perfectly. But now we were on a hybrid course to the moon. And now, if something should happen to the spacecraft, if, for instance, the engine again refused to fire, we were on a course that would take us to the moon. The moon's gravity would swing us around, aim us back towards the Earth, but the closest point of approach back to the Earth would be about 40,000 miles out, much too far out to be captured by the Earth's atmosphere. We didn't worry about it. Everything was working fine. The stars, the sights, the sounds, the smells, everything was so familiar to me. We settled back for a very tranquil 3-day flight to the moon. It was about 56 hours after we took off. The command module and the lunar module were mated together. It was over 2 days out. Our flight plan said now is the time to have a TV program and beam it back to the Earth. I got out the TV camera. Fred Hayes was the lunar module pilot. He floated through the tunnel into the lunar module. I photographed Fred floating around and telling the people back on the Earth what he was looking at and things like that. But you have to remember now, this was the third lunar landing mission. The signal came back to the control center, went out to all the networks, none of them carried it. I was competing with Dick Cavett on one channel, a rerun of I Love Lucy on another channel, and the ball game in Houston was going on, and everybody was interested, including the controllers, in the ball game. I didn't know it at the time, but I did get sort of a subtle message, Jim, it looks great, I think you better shut it down now. And I did, and I was coming back down through the tunnel, carrying the camera, when suddenly I heard a hissing bang, and the spacecraft rocked back and forth quite violently. I looked up at Fred to see if he knew what caused the noise, and I could see from his expression, he did not know what caused the noise. And then I looked over my third companion, a guy by the name of Jack Swiker. Jack's eyes were as wide as saucers. Not only did he not know what caused the bang, he was saying to himself, why am I here? Swiker was not supposed to be there. The prime crew member for his slot was a man by the name of Ken Mattingly. Just 4 days before we were to take off, the whole crew was exposed to the measles. Hayes and I, being married, having kids that had the measles, we had the measles as kids. We were immune to the disease. But Ken Mattingly was a bachelor, never had the measles. No doubt in the doctor's minds that he would get them as he was alone orbiting the moon, waiting for us to come back up from the lunar surface. I argued with the doctors. I said, look, I can't think of a better place to have the measles than in a nice cozy spacecraft around the moon. That didn't get too far, obviously. Swiker was put on board. Now things in the spacecraft happened very fast. A light came on that said something is wrong with your electrical system. 2 more lights blinked on that said 2 out of 3 of your fuel cells have just died. A fuel cell is a device where we take liquid oxygen, liquid hydrogen, combine them, and get electrical power and water. Our mission rule stated that if you lose a fuel cell, the landing on the moon is off, even though just one fuel cell will provide enough electrical power to comfortably get you back home again around the moon. So at that point, there was a wave of disappointment in the spacecraft. This is my second time up here, and now I can't land. I didn't think I was going to get a third try. And then I drifted to the center of the spacecraft, looked up at the instrument panel, and looked at the instruments that told me the condition of 2 huge liquid oxygen tanks that I had in the back of my spacecraft. The needle on one gauge read 0. And the needle on the other gauge, I could actually see going down, something you would never see in the usage of oxygen. And that's when the old lead weight went down to the bottom of my stomach. And I began to realize that we were in deep trouble. And then I drifted over to the left-hand side, past Jack, looked out the window. Can't tell you today why I did it, but I saw escaping at a high rate of speed a gaseous substance. And it didn't take much intelligence on my part to realize that the gas escaping from the rear of my spacecraft and the needle of my second to last oxygen tank were one and the same, and pretty soon would be completely out of oxygen. And when that occurred, because we use oxygen to produce electricity, the third fuel cell would die, we would be completely out of electrical power. And when that occurred, because we controlled our rocket engine by means of electricity, we would lose the propulsion system. We were in deep trouble. We did have, in the spacecraft, a little battery, a little oxygen tank, merely to get us through the atmosphere and that final plunge after we jettisoned everything over the side. But at the time the explosion occurred, we were some 200,000 miles from Earth. We were 90 hours from Earth because we had to go around the moon and come back home again. And of course, we were going in the wrong direction. Well, the ground finally realized what was going on. They didn't believe it at first and said, we better get you back on that free return course. So Hayes and I went into that lunar module, turned on all the systems. It used batteries instead of fuel cells. They told us how to maneuver this combination spacecraft, had to learn to fly all over again. We lit the engine that was called the descent engine, the engine that we normally use to land on the moon. It moved us over to what we thought was that free return course. But then we remembered that the lunar module was designed to only last 45 hours and only to support 2 people. We were 90 hours from the Earth because we had to go around the moon. And when I counted the crew, 1, 2, 3, I knew that we were in deep trouble. About that time, Fred looked at me and said, Jim, we're not going to get home. The batteries are going to run out of power. They're going to go dead before we ever get home. I said, Fred, I think you're right. The ground, then a little while later, with a lot more people working on the same problem, came up and said, you're not going to get home. You're going to run out of battery power. And we said, we already understood that. Do you have any solutions? They said, we have one. As the moon pulls you around to the far side, we'll have you light that descent engine for a second time. Keep it on, maybe for a long period of time, and maybe you can get home back into the atmosphere before the batteries go dead. I said, sounds like a good idea to me. They said, but you know something? We have never tried these procedures in a simulator, so we don't know if they're going to work. We're sending a crew down now into the simulator. If they work, we'll send you up the instructions. And I said, fine. And they said, hey, now don't forget, when you get close to the moon, and you're getting very close now, it's going to pull you around to the back. You're going to lose communication with us, so be ready to copy those instructions. I said, fine. A little while later, they called up, and they said, yes, we think this is going to be okay. I started to copy the instructions. I looked at my 2 crew members thinking they were really listening intently. They weren't. They both had cameras in their hands. One guy was looking at shutter speeds. The other guy was looking at aperture settings, and they're looking out at the moon. I said, gentlemen, what are your plans here? And they said, Jim, as we go around to that far side of the moon, we're going to take some pictures. I said, if we don't get home, you won't get them developed. And they said, Jim, doggone it, you've been here before, we have. We're going to take some pictures for our folks back home. They got their pictures, I got the procedures. 2.5 hours after we left the backside, I turned the engine on for a second time, kept it on for 4.5 minutes, pushing us faster, faster, and faster on the way home. Then we shut it off. Then we shut off all those exotic electronic devices that you would not be caught out there without. You know, the computer with its 37 navigable stars in its memory, the guidance system to tell us how to maneuver, the autopilot to help us stabilize this ungainly mass. Only thing we had on was the radio to talk to the Earth and a little fan to circulate the atmosphere. Things were kind of quiet. And then when they are, you start to think. And when you're in a tight spot, that's bad news. Because you start to think of all kinds of things, and it was Schweikert that came up and said, you know, I think that we're exceeding escape velocity. Let me mention what that is. If I walk outside of the school have a baseball in my hand, throw that baseball up in the air a little over 25,000 miles an hour and just forget the atmosphere for a second, the baseball will not come back. The baseball will not go into orbit about the Earth. It will escape from the Earth and eventually go into an orbit about the sun. I said, don't worry, we're in good shape. Remember, we got back on that free return course, and that course is to guarantee us to have a safe landing back here on Earth. Because what that course would do would put us into a 2-degree pie-shaped wedge. Funnel us right down that 2-degree pie-shaped wedge. That wedge cannot be any less than 5.5 degrees with the horizon, or 7.5 degrees with the horizon. I said, we're in good shape, forget about it. Wrong. I think it was 102 hours after we took off, the ground tracking us on the radar said, we don't know what you're doing up there, but you're no longer on the free return course. Should you continue this course that we've extrapolated all the way back to the Earth, you'll miss the Earth's atmosphere by about 60 nautical miles. I said, well, thanks a lot. You know, we turned off all the nav aids. We have nothing up here. And they said, Jim, you know, we remember that. But do you remember on Apollo 8, those emergency procedures we had in the back of the manual? I said, yeah. I said, I helped develop those procedures. And they said, you know, the one that if the communication system wouldn't work and the navigation system failed? I said, yes. They said, you're going to have to use them now. What that procedure consisted of, the entire procedure, was to sort of manually try to maneuver the spacecraft around, putting the Earth in the window of the lunar module. If you look at the Earth in space, it's got a terminator, a rather sharp line. We call it twilight here, between daylight and darkness. I had in my window a little gun sight, a little reticle. If I could maneuver the spacecraft around to put the horizontal line of my little crosshair right on top of the terminator, it would then place the engine in a proper position to either shallow out or steepen up that angle on the way back if two things would happen. If I had daylight at the top of my window of the Earth's daylight at the top, and if I lit it just at the right time on the way home. That was the entire procedure. I said, Jack, the clock has stopped. Obviously, we don't have it running, but you do have a wristwatch. You tell me when to turn on the engine and how long I should keep it on. He said, fine. He was right in the center. I said, Fred, I know when that engine comes on without any kind of a stabilizing device to help me keep the spacecraft stable, I'll never keep the Earth in the window by myself. I'll take the primary attitude controller and keep the Earth going up and down too much. You take the backup over here and keep it going from sideways too much. He said, okay. On the side of my console, I had two buttons. One said start, and the other one said stop. Direct electrical link from the battery to the engine. One and only time they were ever used in the Apollo program. At the proper time, Jack said start. I hit the start button, engine went on full blast. I jocketed the Earth vertically, Fred jocketed it horizontally. 14 seconds later, Jack said stop, I hit the stop button, and then we waited to see if we got back into that corridor to come on in and make a successful landing. Now, those of you who have seen the movie or read the book, don't tell those that have not seen the movie or read the book whether we made a safe landing or not. I don't want to give away the ending. Actually, we did. We landed in the Pacific Ocean, exactly where we would have only 2 days earlier, and the carrier Iwo Jima was ready to pick us up. Now, I had brought with me a silent film, which I would like to narrate, and it is made for Congress in 1970. They investigate everything. I show some of the highlights of this film, or of the flight. Those of you who have seen the movie, if you want to take a look at the real thing, you can compare the props and the sets in the picture with what you see here to see how accurate they were. So if we can get it all set up, I think it's going to be back here. I'll be moving aside. I think you can still hear me, can't you? Yeah. While they're setting it up, I think I might just tell you what happened here. This accident was set up 5 years before we took off. At that time, NASA told all the contractors of electrical equipment to make the spacecraft compatible with the electrical systems that were at Cape Kennedy, even though the electrical system in the spacecraft, say, flew at 28 volts of DC power. We had 65 volt power at the Cape. We could use that higher power to get the test done a lot quicker. Everybody did it except the fellow that built the heater system in the oxygen tank. And the little thermostat that was in the heater system was designed to only operate with 28 volt power. And when that occurred, we damaged it on a test before the flight. No one ever caught it. And of course the oxygen tank blew up when we turned on the heater system. If we can have the film now, I'll narrate it for you. Call it a quick look. As I said, Fort Congress. That's our Saturn V rocket. It's a shame that we did not keep building these rockets, because when the Challenger blew up, we had no backup. This can actually put more mass in the low Earth orbit than the shuttle can. We paid all the money for research and development and tooling, but we can't build it anymore. That's Fred Hayes. And Jack Schweiker is still trying to figure out how he got on the flight. And my fishbowl helmet is being put on. We're going down to the center on launch day, down the pad. Notice that we keep our helmets on. We're completely suited up because we're purging our bodies now of nitrogen. We're breathing pure oxygen because the spacecraft flew with low pressure, 5.5 pounds per square inch. If you watch a shuttle crew go to the launch pad, you will see that they will not have their helmets on. We learned something from the Russians. They've always built their spacecraft to fly at sea level pressure, and we do that now with the shuttle. It's kind of eerie going down to the launch center on launch day. The rocket is filled with 5.5 million pounds of high explosives. Everybody else is a comfortable 3.5 miles away, except a couple of nervous checkout guys. Now remember, this is 1970. Not 1995, and yet most of our countdown at this stage is computer controlled. That is Kurt Davis, who came in with Dr. von Braun, by the way. Pressures, temperatures, heart rates, everything is checked, everything's okay. About 3.5 seconds before liftoff, the engines are ignited. 5 engines at the first stage, each one producing 1,500,000 pounds of thrust. This is slow motion, showing the liftoff. The flaky material are ice crystals formed by the high humidity at Cape Kennedy and the liquid oxygen inside the tank. Notice the fins on this rocket. Poor Dr. von Braun could not make a rocket without fins. We actually control this vehicle by gimbling the 4 outer engines. And I suspect that those fins are like, ornaments on your automobile. Producing thrust now of 7.5 million pounds. People often ask, with all that thrust, and you're sitting on the other end of that long stick, is your face distorted? Can you move at all? Are you pressed back into the couch? And the answer is it's a very comfortable takeoff, because although we're producing 7.5 million pounds of thrust, the vehicle on liftoff weighs 6.5 million. We're burning fuel now at the rate of 15 tons per second. That's about as much as my '73 Chevrolet I had back in those days. Actually, what it's like to fly one of these things is like riding a high-speed freight train down some rickety old tracks. As the engines gibble ever so slightly at the bottom end of that long stick, you rock sort of violently back and forth in the upper end. It took us 1.5 minutes longer to go into Earth orbit because of the loss of the engine on the second stage. And now you're sitting in Jack Schweiker's lap. You're looking out of the command module window. Jack's job is to dock the command module with the lunar module that's tucked into the end of the third stage that's following us to the moon. On the command module, he has a probe, and he's got to put that probe in that round funnel-like affair in the upper right-hand part of the screen, which is built at the top of the lunar module. He used that little gun sight that I mentioned before, and that little target that's also built on the lunar module with the black circle around it. What I want you to look at as the lunar module gets closer is how flimsy that the lunar module is constructed. The pressure hull is crinkly. It is very lightweight. It is designed only to work in space or on the lunar surface, never, of course, to come back to the Earth. And contrary to the movie, Schweiker was a very competent pilot, and you can notice how steadily he drives that thing in to to dock with the lunar module, and shortly you'll see the shadow of the probe come across the skin of the lunar module as we go on in to dock. And very fortunately, we had a successful docking, otherwise I would not be here today to talk about it. That is the third stage, following us to the moon. The ground has taken charge. It changed its course slightly. It impacted the moon. The force of the impact was picked up by a seismometer left by the previous crew. And from that, we learned a lot about the structure of the lunar surface. That, by the way, was the only successful experiment on this mission. You're now in the Johnson Space Center the second day out. This is the television program that I had mentioned. I want you to look when the camera swings around, the faces of the controllers, how complacent they were, how much they almost were to go to sleep. In fact, this guy on the left-hand side, I think, is asleep. And finally, I got the word, and we cut off the TV. The explosion occurred, and we had to figure out how to get to the moon. My wife, by the way, was in the control center, had left just before the explosion occurred. This is now the dead command module. A little sunlight is streaming in, and Fred has a very wide-angle movie camera. He's swinging around. On the left-hand side, you'll see the hatch come into view very shortly. That hatch closed the tunnel between the two vehicles. And look how closely the props of the movie compare with the actual scenes. Fred will now take you through that tunnel into the lunar module where Schweiker and I are trying to figure out how to get home. Now, in space, there is no up or down. What is to one man's right side up is to another man's upside down. And once your stomach gets used to it, and it takes about 6 hours for the average person, you can have a lot of fun. I mean, you can play around with things, and for you people, you can prove out Newton's 3 laws of motion. And you just have a ball. Notice also the similarity with what you saw in the movie and what you just saw there in real life. We used a zero-G airplane to actually have zero gravity in the movie. Back at the control center in Houston, things, of course, have taken a new twist. What happened and how do we get these guys home again? Procedures that normally took weeks to develop and weeks to test are now being done in just hours. Everybody was brought in, flight controllers, backup astronauts, the contractor people. The fellow in the light blue short sleeve shirt, that is Ken Manley. Can you imagine his emotions? Highly disappointed to be kicked off the flight. Secretly elated he wasn't on it when the explosion occurred. Notice also that I was rubbing my hands because we turned off all the electrical systems, which was the source of the heat to keep the temperature even in the spacecraft. And when we turned them all off, the temperature kept dropping. It got down to about 34 degrees Fahrenheit before we actually got back home again. The vehicle is a little bit bigger than it really looks like because of the wide angle of the lens. Hayes is holding it out at the end of his arm. We were being poisoned by our own exhalation. Carbon dioxide was building up. The lunar module had round canisters, but not enough of them to get rid of the carbon dioxide. We had to use a dead command module square canisters, and you can't put a square canister in a round hole, but we used tape, plastic, and cardboard to do the job, which indicates, ladies and gentlemen, that on a $20 billion program, without tape, plastic, and cardboard, you are lost. We're again sweeping things around. We're trying to barbecue the spacecraft now. And of course, the doctors too were quite worried about us. My heart rate actually got up to 130. That's one of the doctors. Got up to 130 at the time of the explosion. And I did remove my biomed instrumentation so they wouldn't know how scared I was. I told them, we're just saving electricity. I had a little Sony tape recorder on board, and what we're doing right now, though, is barbecuing the spacecraft, rotating it perpendicular to the sun to try to heat up the spacecraft a little bit. And that is the Earth going by at about 110,000 miles out. See how small it is? There's that Sony tape recorder. I had the theme from 2001, which I played. For you older folks, I also had the theme of a movie called Maroon, about a spacecraft that was marooned. I wasn't about to play that theme, though. Schweiker is trying to get a little sleep in the tunnel area. Then on the left-hand side, Fred Hayes is also trying to get some sleep. Notice he keeps his hand in his blouse. On a much earlier spacecraft, Pete Conrad, another astronaut, was flying in a completely darkened spacecraft, and he was trying to get some sleep. He woke up, he saw this eye staring at him in the face. Scared him half to death, he thought it was a UFO. Turned out that his arm had drifted up. He was looking at the luminous dial on his wristwatch. And that, folks, is how those UFO stories get started. Also, we're eating food in zero gravity with a spoon because if it's thick enough, you can use a spoon just like you can on Earth. Trying to store some urine for 3 nourishment for 4 days. We're trying to use every bag we can find. And finally, that last maneuver that I mentioned, the seat of the pants, which is the only maneuver that was shown in the movie, by the way. There's the Terminator of the Earth as we're coming back in. These are still photos now of the service module jettison just before we hit the atmosphere, showing where the oxygen tank exploded, blowing off the entire side of the spacecraft. And then finally, the last two crises we had to overcome was the heat shield cracked. If it was cracked, we would have burned up on the way in. It was not, thank goodness. Would the pyrotechnics fire out the parachutes because they were cold soaked for 4 days? But they did fire, and the parachutes came out, and we came on down in the Pacific Ocean, just about where we would have had this been a normal mission. The task force is very nearby as we slice very gently into the water, and we all, of course, breathed a very good sigh of relief when that occurred. Of course, and they also breathed a sigh of relief back at the control center in Houston. There they are right now, happy that they didn't have to worry about 3 dead guys. The helicopter came over and dropped swimmers in the water to put a flotation device around us. And then right after this occurred, another helicopter came by, number 66, a very famous helicopter. That's it right there. Picked up about 5 or 6 crews. When the movie was made, of course, just last year, all these helicopters were out of service, but they did find one that a civilian had, and they borrowed it, repainted it completely to look like this particular helicopter, number 66, which they used for the movie. You saw this live for the very first time because we had an uplink on the carrier to a satellite in space so that you could see this first recovery live on your television. As we come on off, you're at the control center now in Houston. We wave to the crew, and then, of course, we're going to walk over and give a thanks to the captain. And then the chaplain gave a prayer of thanks for the millions of people who prayed for our safe return. Some 55 countries offered water recovery assistance for us. Even countries like Paraguay and Czechoslovakia, they don't even have coastlines. This is what happens in the control center after every successful flight. I guess they don't smoke cigars nowadays, though. And through that same satellite, we're able to talk to the president and then our wives. I'm talking to my wife. Fred Hayes in the middle is talking to his wife. Jack Swikert, I forgot to mention, was a bachelor. He is talking to every single stewardess on Eastern Airlines. Let me just mention the moral of the story. This was an almost complete catastrophe. I should not be here today talking about it. I mean, we don't train for all these failures. Why am I here? Because of the initiative, because of the tremendous teamwork between the ground and the flight crew, between the motivation of everybody working together to make this a successful recovery. And that's the whole purpose of the Thompson Leadership Lectures, to instill in all of us here a little bit of leadership. Thank you very much. Do we have time for questions and answers? I'll leave it up to my host. We do? Fine. Oh, okay. We have, Dr. Marshall says I have 5 minutes for questions and answers. I'll be more than happy to answer anything that you so desire. Future, past, present. Do we have a question? Oh, yes, speak up.
What are your sentiments on the mission to Mars in the future?
What are my sentiments on the mission to Mars in the future? It will come to pass. When? Probably in the first quarter of the next century. That's 30 years from now, of course. Only because I think that we'll get together. It'll be an international venture. It will not be a U.S. or anything else. We'll all work together to do it. If you pin me to the wall and say, now, Jim, how will this benefit mankind? I can't answer that question right now. But we are a curious animal. We will go to Mars because it is there. And we'll get all the technology from going to Mars, and perhaps a lot of the basic sciences will also occur. We have all the technology today to go to Mars. There are no breakthroughs that are required to actually start out today and build a space system to go to Mars. What it requires is time, money, and effort. When those three things come together and the willpower to do it, we will do it. Yes, young lady. Say that again louder, please. Oh, do we have to join the armed forces to be an astronaut? Definitely not. As a matter of fact, I think most of the people now in the space program, and I went back there, and there's about 100 astronauts, I think, and they all look like little high school kids to me, you know. But they all got their doctorates, they all got their master's degrees, and they're really well qualified. Most of them are civilians. Men and women, civilians. You don't have to be a test pilot any longer. On a flight of the shuttle, I think only 2 people really control the vehicle. The commander and the pilot, they're usually people who are aviation oriented. The rest of them could be geologists, physicists, doctors of medicine, engineers, anything at all, biologists, anybody doing experiments in Space Lab, looking back at the Earth to learn more about the Earth, putting out satellites, both for, of course, for military, but mostly for civilian activities. Yes?
What would you say to students who want to pursue a career in aerospace or space program?
What would I say to students who want to pursue a career in the aerospace or the space program? Well, I think the first criteria is you want to pick a discipline of which you're very much interested in, regardless of what it is. If you want to be an operator, flying, for instance, then of course an aerospace background would be very helpful. But those of you who want to get into our space activities, like I said before, any discipline has to be good, but you have to have the credentials, let's face it. So if you want to go in there, you have to have the necessary expertise to spend the money to put you up in space, because of course it's very, very expensive. But anybody can go. It's open to everybody. It all really depends on how much activity we have in the future, something I really can't predict. Yes? The most important area for, the question was, what is the most important area for future development of a space program? I think it's going to be the space station, an international space station, working not just with the U.S., but a consortium of countries, Russia, European Space Agency, Japan, Canada, and the U.S., working together to put up a permanent orbiting laboratory that can look back at the Earth to learn more about the Earth, to conduct experiments in space under the microgravity influence of space, and of course they look to go outward too with telescopes and things of this nature. I think that is going to be the real thrust. And there's some intangible benefits to that. The one thing that the program has really done ever since we wondered why our educational system wasn't good enough to beat the Russians to put up a Sputnik back in 1957 is the spurt to education. Lots of young people follow the program and therefore are really excited about science and technology and try to further their careers. The second most important intangible is the cooperative efforts among countries. Here is a program that does not have the controversy, I'm talking about the International Space Station, as say Bosnia has, or the tariffs or something like that. We all work together, we have good rapport between countries, and I think that is one of the big assets to our space efforts. That is what I call an intangible. One more? One more question, that's it. Oh, yes, okay. There's an interesting question. What do I think about the single space to orbit, or I think it's called Anyway, a single-space-to-orbit program is a device that McDonnell Douglas is working on. It's a rocket ship that takes off single stage orbit, and it has single stage all the way into orbit, drops off its satellite, turns around, fires it for retrograding, comes back into the atmosphere, fires its engine again, and lands safely. In other words, nothing is thrown away. It has lots of theoretical potential, but I'm from Missouri. I want to see it happen first. I think the efficiencies of the engines required, the lightweight of the spacecraft itself, or the rocket required, is going to be a very hard obstacles to overcome. A very good friend of mine, the person I mentioned, Pete Conrad, is working on it now. He's very optimistic. I'm so. Thank you very much, ladies and gentlemen.
Well, Captain Lovell, I hope you have understood from our applause how much we appreciate your wonderful words and courage. We have a belief statement at the Math and Science Academy that says that good learning comes from both failing and succeeding, and it does appear that you learned well. Thank you very much for your wonderful remarks. We want to thank our over 800 guests. There are materials as you leave if you would like to learn more about the Math and Science Academy programs across the state of Illinois. For the media, we will be having a brief press conference in the West Gym as we end this program this afternoon. And for those of you who will be attending the private reception, there are students who will bring you to the Information Resource Center. Thank you again, and have a good afternoon.